Hello guys, welcome back to my YouTube channel. I am Akshita Patil from Sri Venkateswara College of Engineering, Bengaluru, and the today's subject is Analysis and Design of Algorithm, and the topic is Insertion Sort. Let's start with the introduction to sorting algorithm. What is sorting? Sorting is arranging data in ascending or descending order. So why we need to sort the data? It improves data retrieval and algorithm efficiency. So common types of sorting algorithms are bubble sort, quick sort, merge sort and insertion sort. Now we will see what is insertion sort. Insertion sort is a simple algorithm that builds a sorted list one element at a time. Insertion sort is a comparison based sorting algorithm that builds the final sorted array one atom at a time. So how it works? It iterates through the list to insert each element correctly. Now we will discuss how insertion sort works. So first we will start with the second element, because first element we will consider as a sorted element. Next we will compare current element with sorted elements. Then we will shift larger elements at the correct position, and then we will repeat these steps until the list is sorted. Now we will see the algorithm of insertion sort. We will start from the second element of the array. Since we assume the first element is already sorted, we will repeat this process until the last element. Then we will store the key element, the element we want to place in correct position. Next we start comparing this key element with the previous elements to find its correct position. Then as long as we are not at the start of the array and the element at position j is greater than the key, we keep shifting the larger element to the right. Next, the element is shifted at position j, that is one step to the right. Now again we will compare the next element to the left, and once the correct position is found, we insert the key element there. Now we will see an example of insertion sort. We will take an array that is 5, 2, 9, 1, 5, 6. We will start with the second element, means we will consider first element as a sorted element. First we will compare 2 with 5. So 2 is the smaller one, therefore it will shift before 5. Next we will compare 9 with 5, 2. 9 is the larger than 5 and 2, therefore it will be at the same position. Next we will compare 1 with 9, 5, 2. So 1 is the smaller than 9, 5, 2, therefore it will come at first position. Next we will compare 5 with 9. So 5 is the smaller than 9, so it will shift before 9. Next we will compare 6 with 9. So 6 is the smaller than 9, so it will come before 9. So at last we will get the sorted elements as 1, 2, 5, 5, 6, 9. Next we will see time and space complexity of insertion sort. First case is the best case. In the best case scenario, the array is already sorted. In this case, each element only needs to be compared once, so the algorithm runs in a linear time, that is n. Next one is the average case. On average case, when the input is in random order, each element may need to be compared with half of the sorted part. This results in quadratic time complexity, that is n square. Third one is the worst case. In the worst case, the array is sorted in reverse order. Every new element has to be compared and shifted through the entire sorted part, making the time complexity as n square. Next one is the space complexity. Insertion sort is an in-space algorithm. It sorts the array by modifying the original array and uses only a constant amount of extra space. Hence the space complexity is 1. Next one is key features of insertion sort. First one is the adaptive. Insertion sort works faster if the input is already sorted or nearly sorted. Example is like arranging already sorted playing cards. Next one is the stable. If two elements are equal, their original order is preserved. Example is sorting a list of people by age. Third one is the in place. It does not use extra memory. It sorts the list within the same space. Example of this is, imagine a sorting books on a shelf without needing a second shelf. And the fourth one is online. It can sort data as it comes in. No need to wait for the entire list, like arranging cards one by one as you draw them from a deck. Next one is advantages of insertion sort. First one is simplicity. It is easy to understand and implement. Second one is the efficient for a small data. It works well on nearly sorted or small lists. Third one is the stable sort. It keeps relative order of equal elements. And the fourth one is the in place, that is minimal addition memory required. Now we will see disadvantages and comparison. So first one is the drawbacks. In that, first one is slow for larger data sets. Insertion sort becomes inefficient when the input size is large. It performs many comparisons and shifts, making it slow compared to more advanced algorithms. Next one is the quadratic time complexity. As we saw earlier, in average and worst case, the time complexity is n square. That means the time increases rapidly with larger inputs. Then we will see comparison. First one is the quick sort. Quick sort has an average case time of n log n, which is much faster for larger data sets. Next one is the merge sort. Merge sort is both stable and efficient with guaranteed n log n time complexity. And the insertion sort. Insertion sort is useful for small arrays or nearly sorted data where it can outperform more complex algorithms due to lower overhead. Thank you guys for watching my video. Please like, share and subscribe.